called variables? Because they're variable, right? They can be anything. They change. Where did this thing go? Weird. Okay. A variable is generally a letter. But it could technically be a symbol. It could be a Greek letter. It could be any kind of symbol. Excuse me. And it's used to represent an unknown number. And it can be anything. So they can have any value. Okay, an algebraic expression is different than an equation. An algebraic expression is a collection of numbers and variables. Or to be quite honest, it could just be one number, one variable. Collection of numbers and variables, or just one. Okay, you can have addition, subtraction, multiplication, or division, or combination of all four. The big thing is no equal. Okay, an expression does not have an equal sign. They can be simplified. They can have a value. If your expression is only numerical and you don't have any variables in it, you can simplify it down to a single number value, but you cannot solve it because it's not equal to anything. Okay. So, no solving. Only simplifying. Okay, we can only solve things if they're equal to something else. Okay. In order to evaluate an algebraic expression, we're going to simplify. And we're going to add, subtract, multiply, or divide. Basically, we simplify it. We add, subtract, multiply, divide until all the like terms have been combined, if possible. And no further operations are possible. So we can't add or subtract or do anything else anymore. So that's what it means to simplify, is just to combine everything that you can, and then you stop. Mostly. PEMDAS, please excuse my dear Aunt Sally. This is the order that the operations of math are performed in, because this is the order it was decided that they were performed in many hundreds of years ago. And the reason that we have this is so that everybody given the same math problem, regardless of where you are in the world, will come up with the same answer. Okay. Parentheses are, of course, the key. This is any grouping symbol. Which includes parentheses, brackets, braces, absolute value, bars, underneath a root, fraction bar, so stuff on top and stuff on bottom. Get done first before you do the fraction bar. You do everything in the parentheses first, or in the grouping symbols first. After that, the next thing comes exponents. I'm going to put in here roots in parentheses because the opposite of exponent is a square root. So they have kind of the same weight. So you put those in together. Okay, now in my little world, order of operations is like a royal family, where the parentheses are the king and the exponents are the queen. And the reason I came up with this idea was because I wanted to get it across that even though it goes P-E-M-D, M does not have to come before D. M and D have the same power. So you put them as the prince and the princess. You want to get something done and you're running around looking for the prince and the princess, you're going to ask whichever one you come to first. So they have the same amount of power. So as you read a math problem, you read the same way you read a book. You go from left to right. So whatever one you see first, multiplication or division, is the one you do first. They have the same power. So we're going to put a big OR right there. Multiply or divide in order from left to right. So as you read the problem. If you see division first, then divide first. You don't have to multiply before you divide. As a matter of fact, if you do multiply before you divide, sometimes it works out okay, but sometimes it will give you the wrong answer. And then the peasants, so, you know, the last bit of importance, unless of course they're inside parentheses, are addition and subtraction. And again, these have the same amount of power. They're both peasants. They're both at the bottom of the food chain. This would be like the husband and wife of the, you know, feudal farming people. I don't know. I'm not a history teacher. I'm a math teacher. So you have to find out how that worked from Mr. C or something. But low is part of the food chain down here. But again, in order from left to right. Because while they are below everybody else, they are equal to each other. So, I was saying before, if you're getting something, wanted to get something done, so you run around the palace and you ask the prince or the princess, whichever one you run into first. If you want to order somebody to do something, you run around in the field. You don't care if you run into the female or the male peasant. You just, hey, peasant, you do this now. Same here. This right here, I'm going to plug in our given value. Okay, so they tell us x equals 6. So we want to find out what is 7 plus 5 times x minus 4 to the third if x is 6. So we plug 6 in, and then we do the order of operations from there. So move my box over here a little bit more. Okay, so plug in the 6. So far, okay? Alright, order of operations tells me to do parentheses first, so I'm going to do this 6 minus 4. What happened? Sorry. 6 minus 4 first. The next thing I need to do is exponents. So I'm going to do this part next. 2 to the third is 2 times 2 times 2, so that's 8. Just going to move it up here. Sanders multiplication. And finally, I can add. I didn't solve anything. I was told what x value to use. X could be 6. I mean, x could have just as easily been 10,000. I mean, it doesn't, it's just whatever they tell you, you use that number. Okay. Now, if we done this wrong, let's say I did the 6 minus 4 is 2, and then I did 5 times 2 and then to the third. You see how that would have radically changed the answer, because what I would have had at that point is 10 to the third, which would be 1,000. So this would be 1,007 instead of 47. So that's why you got to be really careful about those. Okay. This is -6 in parentheses. I want to just double check that everybody understands the difference between this and that. I've said this before, people think it's a really weird example, but exponents are like tasers. Okay? They only affect the thing that they're directly touching. So like if you're sitting here in your desk and I come up to your neighbor and you guys are not touching and I taser them, you're not going to feel the shock. Okay? But if you're in a parenthesis together, this is like holding hands standing in water. Okay? So then if the exponent is acting on the parentheses, both the negative and the 6 are being affected by the exponent. So this is -6 times -6. This is negative and then 6 times 6. This negative is not being touched by the exponent, so it just hangs out up front. Okay? So it's really important when you're doing this kind of activity where you're plugging in for x. X is a -6, and that's being squared, the whole thing. So it's parentheses, not without the parentheses.
But if you do it right, but you just forgot to put it in.
That's okay. But I need you to know the difference between these two, because if I gave you a problem like this, or even, say for example, this first example, what if it had been 4 minus 6? You'd have ended up with a -2 inside parentheses. And you need to know that the -2 would be getting the whole thing. So it would be -2 times -2 times -2. Okay. Now, there's another tip. If you have a negative number and an even exponent, is even, your answer is going to be positive.
Or not even.
Yeah, and if you have a negative number with an odd exponent, it's going to be negative. That way you don't have to worry about the negatives as you go along. You don't have to go, okay, -5 times -5 times -5 times -5. You just say, okay, it's going to be positive or negative based on your exponent being even or odd. And then you can just multiply times or whatever. And you don't have to worry about the negatives of that. Instead of plugging in one letter, we're going to plug in 2. So you're going to plug in 4 for x and -2 for y. And see if you come up with the same answer as I come up with. Okay, so an equation. An equation is like an expression in that it has a collection of letters and numbers, variables and numbers. There's addition, subtraction, multiplication, division. The difference is it has an equal and it can be solved. Technically, an equation is a statement of equality with 2 expressions having the same value. Think of it like the old-fashioned balance scales. Like that, you know, and if they're equal weight, the 2 balances, the 2 sides are at the same level. This part right here where the balance is happening is the equal. Solving the equation is getting us down to our letter here and a number here without taking it off balance. So we want to always keep the weight the same on both sides. So basically when you solve an equation, you're moving things around so that they stay balanced. But we know what the letter equals. Okay, a formula is a specific equation. So we're using variables that have been assigned specific meanings. And what they do is they express a relationship. Okay, formulas you're very familiar with. E equals mc squared is Einstein's formula that expresses the relationship between energy, mass, and the speed of light. Okay, distance equals rate times time. D equals RT. It expresses the relationship between distance, rate, and time. You know, these formulas are very specific, and the variables in the formulas are assigned specific meanings. Specific. Specific is not a word. Got ahead of myself. Specific meanings, okay. And formulas are derived from mathematical modeling. Mathematical modeling is finding formulas all formulas have been derived from mathematical modeling. Einstein wasn't asleep, having a nice dream, and E equals mc squared floated in with like wings and said, "Woo, I'm special." No, he came up with that. He developed that using mathematical modeling. Okay. And then the mathematical models are the variables. Okay, that we use to the quantities that we're trying to relate. Now, you can't always find a mathematical model for every real world phenomenon. Sometimes things seem like they relate to one another, but they're not really. Call that a correlation. So you could say that when more people go to the beach, the sale of ice cream goes up. Okay? And both these things could be true, that like the number of people at the beach goes up, the sale of ice cream goes up. But the sale of ice cream didn't go up because there's more people at the beach. And there's not more people at the beach because there's more ice cream sales. They don't affect one another. They're both affected by something else, temperature. Right? So you may see things that are the same or that seem like they would relate, but they don't actually have anything to do with each other, but they may both have something to do with something else. So just so you know that lots of stuff can be mathematically modeled, but not everything can be mathematically modeled. Okay. We know that if you are exercising, you want your heart rate above 120. Okay? And your age affects your heart rate and like the level of exercise you have to do to get to that 120. So we have two types of exercise. Couch potato exercise, this is my favorite. Okay, this would be walking. Low level yoga. One of those exercise balls doing some sit-ups on it, you know. And then you've got working it. This is, you know, really jogging, heavy weightlifting, intense cardio. What is that bike thing that's like supposed to look like, yeah, no, but there's like a class.
Spin class.
Spin class, yeah. Okay, this will be over here. Okay. Now to model where your heart rate will be doing this type of exercise, they came up with these formulas where if you're doing couch potato exercise, your heart rate will be 1/5 times 220 minus your age. Okay. And if you're doing a little heavy impact stuff, minus your age. So there's no bar graph on here. Okay. If I want to do couch potato exercise, I want to see if I can get my heart rate where I need it to be to do that. I'm going to plug in my age, which is 20. I'm going to subtract it from 220, so that's going to be 159 times 1/5. Okay, so 5 that goes in here for 30 works 3 times. That doesn't seem right. Hold on a second. Okay, and this graph showed how many calories we needed to maintain energy. This is the equation for women and any age group with moderately active lifestyles. According to the model, women between 19 and 30 needed 2,100 calories a day. So we're going to look at group X, which is group 4. So we're going to plug a 4 into the equation and see if the graph and the equation are going to match, or at least be close. Okay, so I'm going to have negative 66 times 16 plus 1030. Okay, so 66 times 16 is going to be negative 1056 plus 2104 plus 1030. So according to this, 2078. So our graph and our equation are pretty much dead on. Okay. The mathematical model for men is a little different. You guys, do you want the equation at all? Okay. Okay, so let's talk about terms, coefficients, constants, factors, and like terms. Okay. Terms are separated by addition and subtraction.
Pink Panther.
Yes. Okay. There could be numbers, and they can be variables. And they can be a combo. Okay, these are terms. Term, 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 term. Okay. Coefficients are the numbers attached to a variable. Up front. Okay, so coefficient, coefficient, coefficient. Constants. Constants are numbers. Oh, does that show up? The orange? Can you see that okay? Should I change it?
Green. You and your fascination with green.
It's an excellent color.
There's some cute.
Okay, a constant is a number with no variable. If a variable is called a variable because the value of it can vary and it changes, a constant is called a constant because it's a number by itself and it never changes. The 2 is always worth 2. This 18 on the end is 18. It's not going to change because it doesn't have a variable attached to it to change it. So it's just 18. Does that make sense? Okay, factors make up the terms. Okay, factors make up terms by being multiplied together. So in 7x, your factors are 7 and x. In 4y, your factors are 4 and y. 18 has factors of 2 and 9, or 3 and 6, or 1 and 18. And then finally, we have purple. Like terms have perfectly matching variables. Including any exponents, they have perfectly matched. So 7x and 2y are like terms. 2x, that's what I meant. Circle 2x, I said 2y, I don't know why I did that, but yeah, 7x and 2x are like terms because their x's match. If there's no variable, like terms because that part matches too. If that was 7x and 2x squared, it would no longer match. Commutative property of addition or multiplication only works for addition and multiplication. Commutative property, because the order that you add or you multiply in does not matter. 2 plus 3 and 3 plus 2 are both 5. 5 times 6 or 6 times 5 are both 30. Now with subtraction and division, order does matter because 2 minus 3 is not the same thing as 3 minus 2. Right? And 5 divided by 6 is not the same thing as 6 divided by 5. So it's only addition and multiplication. Same thing with associative property. If you have all addition or all multiplication, the way you group them doesn't matter. 1 plus 2 plus 3, that's 3 plus 3, which is 6. It's the same thing as 1 plus 2 plus 3, so that's 1 plus 5, which is 6. Wouldn't matter how I grouped you guys. Like I could separate you into boys and girls, or I could say you right and left. You'd still be the same number of people. Same thing with multiplication. 5 times 6 is 30, times 2 is 60, or you can do 2 times, or 5 times 12, which is also 60. Again, though, only works with addition and multiplication. Multiplying by sum or difference in parentheses is the same as multiplying first, that's supposed to be a G, and then adding or subtracting. So 5 times 1 plus 3, which would be 5 times 20, or sorry, 5 times 4, which is 20, is the same thing as 5 times 1 plus 5 times 3, which would be 5 plus 15, which would also be 20. So that's the properties that you need to know right now. Alright, whenever you have absolute expressions and you need to simplify them and have parentheses in there, step 1 is always going to be to distribute. Okay, so we're going to distribute this 5 first. Step 3, rearrange if desired. You don't really have to rearrange them, but some people like to rearrange to put the like terms together. Makes it easier. So I'm going to put the 15x and the 6x together. And the 35 by itself. This negative stayed with the 6x and this negative stayed with the 35. They just haven't put the negative. And then step 3 is going to be to add or subtract like terms. $15x minus 6x is 9x minus 35. I can't do anything with those because it does not equal anything, so I can't solve it. And 9x and 35 are 2 different species, so I can't put them together. Okay. Steps will be the same. So first I'm going to distribute. So 6 times 2x squared would be 12x squared. 6 times 4x will be 24x. 10 times 4x will be 30x squared. And 10 times 3x will be 30x. Rearrange if you like to. Again, you don't have to, just if that makes it easier for you, then do that. And then collect 12x squared plus 40x squared is 52x squared. 24 and 30 is 54x. And an x and an x squared are not the same, so they can't go together.